So in this problem here, we're ultimately told to find the area, that's this area here. Now, this area, in order to find it, we need to find the area under the curve minus the area of this triangle here, let's draw a line down, is equal to the area of the shaded region R. Now, in order to achieve that, we must first find the equation of this line here. Now, this is a straight line. We can see that has points 1, 2, and we can easily find that point there. Now, in the question, they said find the equation of the normal, which is that equation line there, and show that this normal passes through B. We're going to do that in one go. And the way we're going to do it is this. We know that's 1, 2. To find that point there, which is on the curve and on the line, we know that that is when y equals 0. So let's substitute y equals 0 into this here. The equation is y equals 3x minus x squared. That's the equation of the curve. If you substitute y equals 0, which is where that is there, look, y there is 0, you'll find the x value there as well. So put y equals 0, that's the equation there. Factorize, take x as a common factor. 3 minus x equals 0. So either x equals 0, which is this point here, or 3 minus x equals 0, which means x equals 3, which is clearly that point there. So here x is 3, and we said from the beginning y is 0. Now we have both points. Now to find the equation of a line, we do as we've done before many times. Y minus y1 equals m, x minus x1. We have 2 points in the line, either this point or this point. We just need the gradient. If you recall, we said the gradient is the change in y divided by change in x. So here, the y value there is 2, the y value there is 0. So the m is going to be 2, because 2 minus 0 is 0, divided by the change in x. The x goes from 3 to 1. That's going to be 2 as well. Because it's going downhill, it's going to be negative. That's the m. Y minus y1. Let's take this point here. Any point will work. Let's take this one here. Y minus y1 equals m x minus x1. Simplify. So we get y minus 2 equals minus, expand at the same time, minus x plus 1. So y equals minus x plus 3. That's the equation of that line there. Now, show that this normal passes through the point B. So, to show that it passes through the point B, what we can say is we can substitute 0 into there, into that x there, and we'll show that y is equal to 3. So it shows that it passes through. But we're more interested now is in finding this shaded region here. So the shaded region, like I said, is the whole area minus the triangle gives you that. To find the whole area, you have to integrate the curve between this point and this point, between 3 and 1. To find the area of the triangle, all we do is half base times height. So the area of the triangle, I'll put it here, area of the triangle is equal to half of the base. Now the base is going to be 3 minus 1, that's the length there, the x value, times the height, which is 2 and 0, so the height there is 2. So that becomes 1, 1 times 2 is 2. So the area of the triangle is equal to 2 units squared. To find the area under the curve, we simply integrate. So it's going to become the integration between 3 and 1 of our curve. Very simple integration. Dx. That's equal to 3x squared over 2 minus x3 over 3 between 3 and 1. That means you substitute 3 minus you substitute 1. Start by putting 3 inside. So it becomes 3 over 2. 3 squared is 9. Minus 3 to the power 3 is 27 over 3. That's 9. Minus, substitute 1. 3 over 2 times 1 is 3 over 2. Put 1 in there, becomes 1 over 3. Plug all these numbers in, and you get a value of 10 over 3. So the shaded region here is going to be this minus this, because that's on the top, it's higher. So it has more area. So the bigger area minus the smaller area gives you the area in between. So the total area, the final area, is 10 over 3 minus 2, which is the same as 10 over 3 minus 6 over 3, which gives you 4 over 3.